Hello. The screen is visible.
Yes, sir.
Okay. So after some 2 to 3 days, we are coming back to the electrical measurement and instrumentation subject. Just in the last class, we have discussed about the ohm meter. There are mainly two types of ohm meters are there. Those are the series type ohm meters, shunt type ohm meters are there. These ohm meters are used for the measurement of resistance. We are going to measure here now, especially the insulation resistance. We can call that one here now. So in resistance and to check the continuity, we are going to use this types of ohm meters. In the previous class, we have discussed, I don't know how many of you were remembered that if the resistance is low, suppose if it is series type ohm meter, series, and here I will write the shunt here now. I will write the shunt here now. Based on the current measurement, by using the based on the instrument full scale deflection, that is called the current flowing through the circuit meter, we are going to identify the resistance here now. Here the unknown resistance, that is called Rx, I am going to write. If Rx equal to 0, then what is the value of the scale here now? It may be full scale deflection or 0 here now. That for the series and shunt. The last class I have in the table, I have shown that one. Now you tell me that one. For the series circuit, what is the scale here now? Full scale deflection or 0? The meter, it is going to indicate 0 or full scale here now. For the unknown resistance is 0.
Full scale.
Here full scale. Some people they are telling full scale. Any other answers? Okay, next here. For the shunt type.
0.
0 or full? Think one answer came, that is called 0. Okay, any other answers other than this full here? Any one of you can tell that one. Already we have discussed this thing. Just say that one. If it is full or 0, two options only are there. One person is saying that it is for if the unknown resistance is 0, then the series ohm meter it is going to deflect fully. But another answer is also there, that is called 0 here. Now here shunt 0 C is saying that no, another answer is there, full is there. Out of these two, full and 0, which one is suitable here now? Roll number 1. Shobna. Roll number 1.
Yes, sir.
What is the answer, madam? They were the absent for so many classes, sir. Roll number 1. And roll number 12. Monica. Roll number 12.
Yes, sir.
What is the answer, madam? Roll number 30. Sagar Patil. Roll
Yes,
number. What is the answer, Sagar?
किसका सर?
हाँ?
और एक बार को
वो क्वेश्चन ही मालूम नहीं है फिर.
हाँ.
Then what you are doing joining the lecture? Sagar Wagmore, roll number 38.
Yes, sir.
What is the question?
I am joining late, sir.
Joined late. Rule number 20. Gore Vinayak.
Yes, sir.
What is the question? Rule number 14. One four. Prajakta.
Yes, sir.
What is the question, madam?
When Rx is 0, what is the series current?
Okay, what is the series current and what is the sent current? That is the question. Okay. So rule number 30, Sagar Patil, you will understand that one. If Rx is 0, unknown resistance is 0, then the series current is 0 or full and sent current is 0 or full here now. You have to choose any one options here now. Somebody told of already full here now, somebody told 0 here, somebody told 0 here now, somebody told full here now. In these two options, which one is suitable, you have to tell me. I will erase all the options here now. Yes, yes, roll number 30. Sagar.
हाँ सर, सीरीज मैक्सिमम रहेगा, सीरीज करंट.
The current will be maximum.
हाँ.
Is nothing but full only, I will write. Okay. Full.
शंट पे 0 रहेगा करंट.
Sent पे 0 रहेगा. Next for the roll number 38. Sagar Wagmore. We'll check later. Okay. Next, Rx equal to, suppose it is infinity. Then what is the value of current in the series ohmmeter and what is the value of current in the shunt ohmmeter?
Series is 0 and shunt is maximum.
Series is 0, shunt is maximum. I am asking for roll number 38. Sagar Wagmare. Your voice is not audible. Sagar.
Yes, sir.
Huh. Don't tell me only yes, sir. Give the answer. If the Rx is infinity, then what is the value of current and this current, series current and shunt current? Sagar, is it audible?
Yes, sir.
You are telling only yes, sir, only. You have two options, 0 and full. Which one I have to write here?
0.
Here, 0. 0 or full?
0, sir.
Here?
Full.
Okay. So this one we have discussed in the previous class that. Okay. So if Rx unknown resistance is 0, then what will happen in the series ohmmeter? It will display the full scale current over there. If it is displaying full scale current, then we have to think that one, the resistance, unknown resistance is 0 for the series type of ohmmeter. For the shunt type of ohmmeter, whatever the Rx value is there, it is proportionally, it is going to show that one here. So for the shunt type of instrument ohmmeter, the Rx is directly proportional to the current. Here 0 is there, here 0 is there. For the series type of ohmmeter, the unknown resistance is inversely proportional to the current here. Now, if the current is 0, but the resistance is 0, the maximum current is maximum here. Now, if the resistance is high here, full is there, but the current is 0 here. Now, so series ohmmeter current is inversely proportional to the unknown resistance, and shunt ohmmeter current is directly proportional to the unknown resistance here. Now this one we have already discussed in the previous class with the diagrams. These two diagrams we have already discussed about that one. Here, if the unknown resistance is more, no current will flow here. Now 0 it is going to display because it will act as an open circuit here. Now if the, so it is maximum, if the maximum current is there, so the current deflection will be 0 here. Now so it is maximum here, minimum is there. If the resistance is 0, then it will act as a short circuit and all the currents will flow here now. So maximum current will flow here now for the series type. Similarly for the shunt type, here the parallelly it is connected here now. So here if the resistance is 0, then what will happen? all the current will flow through this one here, like this through a meter. It will act as open, so it will act as a parallel branch and it will flow here now. So if resistance is 0, then what will happen? Sorry, all the resistance is 0, then all the currents will flow through this short circuit path only. No current will flow here now. So deflection will be 0 here now. If the resistance is 0, then 0 here now. What will happen if it is infinity? The opposition will be occurred here. No, it will act as an open circuit. Then what will happen? It has only less resistance here. No, so all the current will flow through the meter. It will display the full scale. It is going to display for the maximum resistance here. No, so it is directly proportional to the unknown resistance. You can say that one. 7 ohm meter current is directly proportional to the unknown resistance here. So these things we have discussed here now. So actually, every houses you can see your houses and anywhere in the hotels and all the things. So example I will give. All of you will use the iron box. Iron box use karte kya?
Sir, sound break hota hai, sir.
Other people's, can you reply? Anybody? Is the voice is breaking? Other people's, you can reply.
No, sir.
No, then
No, sir.
see, to whom it is breaking means that is your network problem only. If it is breaking for one person, then it is your network problem. If breaking voice is breaking for all the peoples, then it is my network problem. Okay, so all of you will use the resistor, sorry, iron box you are going to use. है क्या iron box आप सबके पास? Use the iron box, fridge, washing machine use किए क्या नहीं?
Yes, sir.
Yes.
Okay. See here, to operate the fridge, washing machine, AC, whatever the fan and all the things, one phase and one neutral is required. Okay, 2 wires are enough. But in the plug, they will provide one bigger plug point they are going to provide here. Okay. है क्या ऐसा point है ना आपके घर में switch board में देखो आप, like this the switch they have given here now. Yes.
Yes, sir.
So it indicates here one is phase. We are going to consider one is phase, another one as neutral. What is the third point? This one.
Earth.
This is the earth point here now. This is the earth point. So earth point means the all the body parts of the fridge, washing machine, iron box, it is connected to here. If any leakage is there anywhere, then what it will do, directly it will send it to the earth here. It will send to the earth without harming to. If you touch the instrument, nothing will happen because it is going to send to the earth only. It is going to send to the earth here. So just think that one. All the currents, it is whatever the leakage current is there, it is passing to the earth means. So earth should have high resistance or low resistance.
Low resistance.
Low resistance it should have to. Earth should have low resistance. So for that reason only we are going to tell that one. Every houses, whatever the electrical appliances are there, for them the earthing should be necessary here. No, earthing should be done over there. So anywhere you visit, any house, any of your friend, relative house you visit over there, the third point they are going to provide it over there in the socket. But I don't know that is connected to the earth or not. I don't know that one. How many people they have done earthing for their houses? I don't know about that. So earthing, what it will do, it has very less resistance here. No, whatever the leakage current is there, it is going to send it to the earth over there. So it is not harmful to the humans over there. Suppose if you have not done the earthing नहीं किया आपने, इधर provide किए उधर तक जाके वो रुक जाएगा. Okay, suddenly if you are using the iron box, आप क्या करते हैं? Iron you are going to touch. You are going to use the washing machine. You just think that one, the outer layer inside that steel part is there. You will touch that one. You will experience electrical shock over there. If any leakages are there, then you will get the electrical shock. If earthing is there, you are not going to get the electric shock because it is bypassed to the earth. So to avoid that, So everywhere earthing is there. Some I think when you are new in the newspaper and news, you can observe that one. The main line was cut and it is felt on the road, and some people they have expired because of electrical shock, like that. You have heard that one. So earth resistance is different for different places. It is less only, but we have to identify the low resistance path. We have to identify where we are going to get the low resistance in the earth here now. For that reason, we are going to measure the earth resistance by using a earth tester here. We are going to measure the earth resistance, that is called, which was instrument name to measure the earth resistance is called earth tester. We are going to call that one. The instrument name is earth tester. Okay, so you have you studied this earth tester in the diploma?
Yes, sir.
Yes, then very good then. So the earth tester we are going to use for the measurement of the ground resistance. We are going to use that one here. Now the definition is the instrument used for the measuring the resistance of the earth is known as earth tester here. Okay, so we are going to measure the ground resistance here now, that is called earth tester. We are going to call that one here. Just a minute, we'll come back. So the earth tester is nothing but the measurement of ground resistance, the earth resistance. We are going to measure that one. So the device which is going to measure the resistance of the earth is known as earth tester. We are going to call that one here. So the instrument used for the measuring the resistance of the earth here now, or earth resistance here now. So all the equipments of the power system here now, it may be power system equipments, means it may be generation, transmission, distribution, whatever the residential, commercial, all the electrical appliances are there. It should be earthed over there, connected to the earth through a earth electrode. We have to connect that one. Okay, through a earth electrode. Every houses should have to be done the earthing over there. So then it will protect from the equipments also. I think you may heard that one during the rainy season and all the things, because of the light fluctuation and all the things, suddenly the TV and house, whatever the TV, washing machine, it is blasted. Like thing, have you heard so many things? Nowadays it is reduced, but previous years when in my childhood we were hearing about that words over there. Because of the some hotels and all the things, you may heard that one, it was short circuited. Because of the short circuit, it is burned completely. Have you heard that one? Anybody?
Yes, sir.
The TV is damaged because of the high voltage, like that. So all the things, these all we can protect if our house is well earthed over there. We are using the earth pit and it is all appliances are earthed, then these damages we can protect that one. So the earth protects the equipment and personnel from the fault current over there. If the faulty current is leakage current or fault currents that is going to flow through the body or through the equipments or through the appliances, then what will happen? It is going to bypass that one into ground, to the earth or ground, we are going to call here. So the resistance of the earth is very low. We are going to call that one here. Very low. It may be 0.05 ohms. We are going to call that one here. Wherever we are going to get 0.5 up to 5 ohm is acceptable, but where we'll get the less 0.003 also, that place is very good for the earthing. We can observe that. So the fault, the earth resistance should be very low. I told that one here now. It is very low. Mudul. So the earth electrodes control the high potential of the equipments here. These electrodes are there, whatever the earth electrodes are there, those are controlling the high potential of the equipment. High potential is nothing but high voltages they are going to control here now, which is caused by the high lightning surges. Lightning surges means malum hai na, all of you?
Yes, sir.
In the rainy season, we are going to get that lightning will occur at that one. Suddenly the sound with light it will come, that is lightning strikes, and voltage spikes we are going to call it. This voltage spikes means suddenly during that one, suddenly it is the voltage will be increases over there. See, normally we are going to get like this voltage, okay? We are going to get like this voltage, but during this session, suddenly the voltage will increase like this. The voltage spikes we are going to call here. So the neutral of the three-phase circuit is also connected to the earth electrode for their production. What is that one? The neutral of the three-phase circuit is also connected to the earth. If in the three-phase anywhere the leakage is there, all the terminals they are going to connect in the neutral point only, which will flow through the earth here. Now the path we are going to provide here. Now, this is 1, 2, 3 phases are there. This junction point, it is also connecting to the earth only. So before providing the earthing to the equipment, हमने equipments को we want to provide the earthing point to any equipment. So before providing that, it is essential to determine the resistance of that particular area from where the earthen pit can be dug here. So we can use some aluminum earth rod, we can use that one copper rod, or some plate we can use that one. That is called, what we are going to call, that is earth pit we are going to call that one. Earth pit we have to do that one here now. So in your house, suppose your house is 30-40 is there, in this 1200 square feet, where we have to do, in which area it has less resistance, that one we have to choose that part. Wherever it is, by checking the earth resistance, we have to check the low resistance area, we have to identify that one by using a earth tester here. The earth should have low resistance so that fault current easily passes through the earth here. So if the earth current is less, then easily we can pass the whatever the leakage is there or faulty current is there, we can pass that one into the earth over there here. So the resistance of the earth is determined by the help of earth tester here. Now by using the earth tester, we can determine the resistance of the earth, we can determine here. Now this is just introduction of earth tester here. Now next what we will do, we'll discuss the next construction and working of the earth tester. So the construction of earth tester we are going to discuss here now. So mainly the earth tester has a rotational current reverser, rectifiers is there, commutator is there, potential coils, pressure coils, current coils, like that. These parts it consists actually. This earth tester, it is going to use the hand driven generator like a megger. All of you have seen the megger, like that. It is also uses the hand driven generator, it is going to use here now. Hand driven generator it is going to use here now. So the rotational current reverser and rectifier are two main parts of the earth tester here now. We are using the commutator. We are going to use the commutator which is connected to the current reverser, and the rectifier we are going to use here. This hand driven generator we are going to operate because the PMMC instrument we are going to operate here. Now that one PMMC instrument, it is operating for AC or DC?
Only DC.
Only DC we are going to use here now. So for that reason, it is going to operate, and one, the current reverser and rectifiers are mounted on the shaft, the DC generator here. Now we are going to use the DC generator. So this consists of rotational current reverser and the rectifiers are there. Have you heard the name of rectifier? Anyone?
Yes, sir.
What it means, rectifier, what it will do? It converts
AC to DC.
AC to DC. And the current reverser, actually it is going to current reverse. If it is DC, then it is going to make as AC like that. Current, it is going to reverses that one here now. That is called current reversers we are going to call, which is connected to the, that is commutator we are going to call later here. So the current reverser and rectifiers are mounted on the shaft of DC generator here. So if we are using a DC generator, the shaft of the DC generator, it is mounted on the rectifier and the current reverser, both were mounted on that one. Okay, next, the earth tester works only on DC here now because of rectifier here. Now we are using the AC to DC, we can convert easily here now. So for that reason, and one more, we are going to use the same operation like a PMMC inside that one to show that one here now. So it is going to operate or works on DC only here. Number 18. Okay, it is going to operate only on DC here now. The earth tester, it has two commutators placed along with the current reverser here now. There are two commutators are there which will place along with the current reverser and the rectifier here. Two commutators are there, means two current reversers are also there and two rectifiers are there here. Now the earth tester has two commutators placed along with current reverser and the rectifier here. So each commutator consists of 4 fixed brushes are there here. I think you have studied the machines part, you have studied that one. The machine, DC machine has the commutator. Yes. Commutator is there. The commutator is the rotating part or fixed part it is? I'm asking to you people, so they unmute के connecting. Sir, question मत पूछो, ऐसे बोल रहे हैं. So which is connected to the motor shaft, we are going to connect that one here. Now it is a commutator is a rotating part here. Now for that reason, to give the, for the rotating part, to give the supply and to take the supply, what we have to do, we have to connect the brushes here. Now for that reason, the commutator is a device, each commutator consists of 4 fixed brushes are used over there here. Now the brushes will touch the commutator parts and it will takes the supply and it can give the supply over there. So the commutator is a device used for converting the direction of flow of current here. It is going to convert the direction of flow of current here. Somebody, anything you want to tell? Yes, somebody has told something. Okay, so it is connected in series with the armature here now. So the commutator is connected in series with the armature of the generator here. Now we are using a generator, this generator, in that one in series with the armature, it is connected here now. And brushes are used for the transferring power from the stationary parts to the moving parts here now. From the stationary parts, it will take the power supply and it we can transfer to the moving parts here now. So the arrangement of brushes can be done in such a way that they are alternately connected with one of the segments even after rotation of the commutator here. After rotation of the commutator, they can alternately connected to the one of the any segment, we can connect that one here. No, so brushes and commutators are always connected to each other here. The brushes and commutators are always connected to each other here. Now like this, we are going to fix the brushes here. Now the four, my fingers are touching like this, they are going to touch over there here. Now I'll show the diagram for you people here. Now the earth tester diagram already you have studied, you told, see here. Now this is the earth tester diagram here. Now it has two pressure coils and two current coils here. Now so one pair is connected here, another pair of the pressure coil is connected here. Now see here, it consists of DC hand driven generator here. Now this is a generator, hand driven generator we have used here now. And this is the shaft of that one, whatever this black lines are there, shafts are there. See here, the green color, these two indicates one is rectifier, another one is current reverser. One is rectifier, another one is current reverser here. Now so for the rectifier, two terminals are there, for the current reverser, two terminals are there here now. So total four brushes are there. This is one commutator, this is another commutator here. So this is the shaft of the generator here. So this shaft of the generator, it is connected to the commutators here. No, so each commutator, it has four brushes here. No, 1, 2, 3, 4 brushes are used here. Four brushes are used here, and it consists of two pressure coils and two current coils here. Now this pressure coil P1 and pressure coil P2 we are going to call, and the current coil C1 and current coil C2 we are going to call that one here. C2 we are going to call that one here now. So this earth tester, it has three electrodes are there, that is called E1 we are going to call, that is earth electrode, and potential electrode and current electrode we are going to call that one here. From this we are passing the supply here. Now we are going to pass the supply from this here now. So in between that P and E1, what we are going to measure? We are going to measure the potential difference between E1 and P electrode here. E1 and P electrode, we are going to identify the voltage here now, that is potential rod we are going to call, and from this C electrode we are going to measure how much current is flowing here now. So in between these two fixed, that is whatever the what is that one, fixed magnet, in between that fixed magnet we are using one potential coil is there. What will happen, this potential coil, it is attached to the spindle here now, the spindle through a pointer here now. So if it is more rotated, the potential coil will rotate, then the spindle will rotate and pointer will rotate. But this potential coil, it is based on the ratio of the voltage and current of this earth voltage between E1 and P, and to the current flowing through this one, it is going to operate here. The potential difference between the earth potential voltage or earth voltage and current flowing through that earth electrode, based on that it is going to operate here now. So if any difference is there, then that much difference it is going to detect here now. See here, so from this one we are, but when while passing the current through a earth, the alternating is required here. The alternating is required, some chemical reactions will not happen and all the things. For that reason, what will happen, we are passing the AC into the earth here now. And see here, from this one, it is one parts we are going to connect this one, the suppose around 1 feet difference we are going to fit that one. So what will happen, potential difference between, I will take the annotate here now, the potential difference between from here to here, it is going to measure the voltage here now. It is going to measure the voltage here now. So these two are in very less space, we have to fit that one. What will happen, so the current flowing through this one, how much it is there, it is going to give the current value, this pressure coil P electrode, it is going to give the voltage value here now. So these two, whatever the alternating is there here, the alternating will pass through the rectifier here now. Here also the rectifier is there. So rectifier, what is the function of rectifier? What is the function of rectifier? It will convert AC to DC.
Yes, sir.
So this alternating current is converted into DC, and this potential coil, it is always connected to the shaft of the DC generator here now. So based on this difference or ratio, the voltage ratio and current ratio, by taking this one, the potential coil, it is going to operate here now. The electrode P, it will give the voltage value. The electrode C, it will give the current value here now. So the potential or the ratio of the voltage to the current, which will give the potential coil, it is going to operate here now. So it is the difference is there, that based on that, it is going to potential coil will operate. If the coil is produces some voltage, means what will it will the rotated means, then what will happen? The pointer and spindle will rotate. The pointer will give the some value here. So this is the construction and working principle of the earth tester here now. So this one with the diagram I have explained. If you want more details, then I will read the slide and I will explain also. Just a minute. I'll take the next slide. See here. So the earth tester, it consists merely 4 coils are there actually. I told 4 coils. One is 2 pressure coils, that is pressure coil P1, P2 here now, 2 coils are there, and 2 current coils are there, that is current coil C1 and C2 here now. So 2 pressure coils, 2 current coils. Total how many coils are there? 4 coils are there. So the earth tester consists of 2 pressures and current coils. So each coil has 2 terminals here now. It has 2 terminals here now. This one is connected to the rectifier in it, or we can consider this one as to the commutator. Another one is connected to the earth electrode here now. So these two are shorted here now, and it is connected to the electrode E1 here now. Another one is connected to the commutator here now. And P2 and C2 pairs, these are one terminal of the P2 is connected to the rectifier, another C2 one terminal is connected to the rectifier, another terminal of P2, the pressure coil 2, it is connected to the P electrode, and another terminal of the current coil C2 that is connected to the C electrode here now. Total 3 electrodes are there here. So the each coil has 2 terminals. The pair of the pressure coil and current coils are placed across the permanent magnet here now. We have placed this one across the permanent magnet. We have placed this one here now. The one pair of the current and pressure coils is short circuited and it is connected to the auxiliary electrode here now. This is auxiliary electrode we are going to consider. It is, these two are short circuited here. Short circuited, P1 and C1 is short circuited and connected to the auxiliary electrode here now. So one end of the pressure coil, the one end of the pressure coil is connected to the rectifier, and the other end is connected to the earth electrode here now. So that pressure coil, whatever it is connected here now, P1, C2, P2 and all the things, one is connected to the rectifier, other is connected to the earth electrode. It is nothing but similarly the current coil is connected to the rectifier and earth electrode here now. This C2 also, it is connected to the rectifier and earth electrode. One is connected to the rectifier and another one is connected to the earth electrode P and C here now. So the earth tester consists of potential coil which is directly connected to the DC generator here. In the diagram actually we have not shown here now. See here, this potential coil is there inside that one here. In between this magnetic field, potential coil, we have written the word here now. We have to show inside this one. This is potential coil. We can consider that one, and it consists of current coil also here now, both. Okay. So the earth tester consists of potential coil which is directly connected to the DC generator here. It is also directly connected to the DC generator. So the whatever the potential coil is there, it is placed in between the permanent magnet here now. This, just think that one, this is the potential coil here now. Here the south pole and north pole we have used. fixed magnetic field is produced here now. Permanent magnets we have used here now. In between this, the potential coil is placed here now. So the potential coil is placed between the permanent magnet here now. The coil is connected to the pointer and the pointer is fixed on the calibrated scale here now. The potential coil is connected to the pointer over there. So the pointer, it is going to fix on the calibrated scale, it has fixed over there. Based on that scale, it is going to operate over here. So the pointer indicates the magnitude of the earth resistance. Whatever this pointer is there, it is going to indicate the how much the earth resistance is there. It is going to indicate that one here. How it is going to deflect, how it is going to indicate the deflection, whatever the pointer deflection is there, it is the deflection of the pointer. It is completely depends on the ratio of the voltage of pressure coil to the current of the current coil here. The whatever the deflection is there, angle of deflection of the pointer, it is completely depends on the ratio of voltage of this pressure coil P and current of this current coil C here now. So see this definition, the deflection of the pointer depends on the ratio of the voltage of pressure coil to the current of current coil here now. See, two current coils and pressure coils are shorted here now. That is auxiliary electrode we have told here now. But this pressure coil, it is going to give the potential or voltage, it is going to give. This current coil C2, it is going to give the current here now. So the potential coil, it is going to operate. If it is operated, then the pointer will operate here now. So the pointer of this meter, it is going to deflect, or it is completely depends on the ratio of this voltage of pressure coil and current of this current coil here now. So that is the working here now, main operation here now. So in this one, we are going to use the short circuit here now, short circuit of pressure and current coil. That short circuit current passes through the equipment to the earth is alternating in nature here now. Whatever this shorted current is there, it is passing the alternating current, it is going to pass into the earth here now. Thus, we can say that the alternating current flows in the soil. This alternating current reduces the unwanted effect of the soil. Whatever the direct means, only that path it can create the holes and all the things. So alternating path, it is going to create unwanted, whatever the effects of soils are there, it can reduce us here now, which occurs because of chemical actions or because of production of back EMF also, it is going to produce. For that reason, we are going to pass the alternating current in the earth here now. So my suggestion is that every houses should be earthed. We have to use the earthing bit. You can check your houses, they have done the earthing in proper way or not. If you don't want to get the electrical shock, it is hazardous of electricals, then you have to do the earthing of that one. I will ask one question. How many of you people, all of you are staying in a home now? Yes. How many of you in your houses, the earthing is there? Just raise your hand. I'll check that one. Only 1, 2, 3, 4 members, 5 members, 6 members, 7. Out of 26, total 26 except me, 25 only. Out of 25 students, 3 plus 3 plus 8 members are there. Out of 25, only 8 students, your houses are earthed. You are studying electrical engineering. So you should know about what is the benefit of earthing, what is the useful, what is that one. Even in your area, if the hotels are there, lodgings are there, any whatever that tourist places are there, you have to suggest that one. If your house is earthing pit is provided, what is the resistance of that earthing, you have to ask that one. Have to check. You can, if the electrical auditors are there, they are going to check this one only, the electrical earthing is done or not. Then if it is done, then what is the resistance of that earthing pit? They have to check maintenance. Even some places, I think you have seen or not, some salt, charcoals, and all the things they are going to dig into the earth to provide the conducting path over there. To reduce the earthing, they are going to pass that one over there. So surrounding that one, they will put the water, salt, and all the things. So easily it can transfer the whatever the leakage is there to the ground over there. Okay, any doubts? The earthing resistance. Any doubts?
No, sir.
So it completes the earth tester. Next we'll go for that is called the dynamometer we are going to use here now. So actually we have already discussed the electrodynamometer part we have discussed in the very first only. So I'll ask that one here now. The dynamometers, what are the main the dynamometer is the iron cored or steel cored or air cooled here. Air cored. Air core material or steel core or iron core. Out of these three, which one is correct answer here? Dynamometer is iron core or steel core or air core. Instrument, we can tell that one. The next part we are going to discuss, that is called single phase electrodynamometer power factor meter here. Now we have to measure the power factor. Before that one, you should have to know that one, the electrodynamometer part we have discussed already. EMMC we are going to call that one. Electromagnetic moving coil instrument we have discussed already. We have discussed it or not? Roll number 34. Roll number 34. Are you there? Sunil. Roll number 34, Sunil. Unmute. Sunil, are you there?
Yes, sir, both.
What is the time now? कितना हो गया time? कितना हो गया बेटा time?
2 sir.
कितना classes attend किए तुम? B division 34 absent. 34 absent. So many classes you are absent. I have not attended my classes sincerely. You have to be present. This is very worst condition. Every time you will join lately. Hardly another 2 minutes I am going to take. You have attended, so I am not going to give the attendance for you. Roll number 34. So see here, the three options I have given to you. Out of that one, that is coreless instrument we are going to call, that is air core. Air is act as a core inside that one. Yeah, I think you have heard that one. Two fixed coils in between that one moving coil we are going to use. Half of the fixed coil in one place, another half of the fixed coil we have to keep another place, like that. So based on that, we are going to operate this single phase supply by giving to the electrodynamometer. We can measure the power factor of that supply power factor we are going to consider. Can you tell me what do you mean by power factor? You are already junior engineer, your level of junior engineers. You have qualified for the junior engineers now. So you have studied this one, but I will ask the very basic questions. What do you mean by power factor? Can you tell me the formula of power factor? Power factor means what? Is it?
Cosine angle between voltage and current.
What? Once again, come once again, madam.
Cosine angle between voltage and current.
Very good. Cosine of angle
Additive
between
product of voltage and current.
So that cos phi, wherever you are going to use the power, you are going to use here now. P equal to VI cos phi is there. This cos phi, it indicates the power factor here. The cos phi is there. It indicates the power factor. It is going to indicate here now. So cos is nothing but that is the cosine we are going to tell that one. The phi, it has very meaning here now. Phi is the the angle, phase angle we are going to call. The phase angle is nothing but the angle between voltage and current we are going to call this one. The angle between voltage and current, that is the cosine of phase angle between voltage and current, that is going to call as power factor we are going to call them. See here the voltage is there like this, whatever it is, leading power factor or lagging power factor. So this angle, whatever the phase is there, that is phase angle we are going to call. Whatever the difference is there, phase difference, or that is phase angle we are going to call, that is called phi, and the cosine of that phase angle is give the power factor, it is going to give that one here. So this actually single phase electrodynamometer, the dynamometer you have to know, and the power factor means you have to know. This part will continue in the next class. Now in the 5 minutes we cannot explain this one, so the components are there here. So this is the circuit diagram of the single phase electrodynamometer, and this one, based on this operation of this electrodynamometer, how the coils are there here, 2 coils are there, how it is going to operate. Based on that, we have to draw the phasor diagram also here. Based on that, we have to draw the phasor diagram of this single phase electrodynamometer. This part will continue in the next class. We will continue here. Just a minute, I'll take the attendance. 1, 2, 3 present. So number 4, 7, 9, 11, 15, 17, 19, 24, 27, 31, 34, 35, 36 is present, 37, 38. So roll number 34, I have not given the attendance again today because you joined late. So only 5 minutes you have attended the session here now. So I'll stop here only and we'll continue in the next class. Thirty-eight present hai beta. No need to worry, number 38 is present.